the world in which we live. At the start of the new millennium, more than 6 billion human beings will be sharing the living space and the limited resources on our planet. The resulting global challenge will be sparing and environmentally conscious use of available energy reserves. Diverse power-generating companies will be linked, and the energy reserves of distant regions of the Earth will be exploited. The vision of the global link calls for absolute reliability at all levels of power transmission and distribution to make sure that electrical energy will always be available everywhere. Power demand continues to grow in conurbations. Top performance, high-voltage switchgear in the load centers takes care of reliable transmission and distribution of the required energy. But nowadays, there is no space for such air-insulated substations in densely populated areas. Their size is determined by the limited insulation capacity of air. This calls for substantial clearances between live parts. This is why Siemens has been utilizing the good insulation properties of SF6 gas in metal-enclosed high-voltage switchgear since 1964. Continuous enhancement of enclosure shapes and production methods has enabled triple pole encapsulation of the busbar in the narrowest of spaces, even at 245 kilovolts. Result, this extensive outdoor substation for 245 kilovolts can be replaced by a metal-enclosed SF6 insulated system that needs only 1/50th of the previously required floor space. It is part of the extensive product range of gas-insulated high-voltage switchgear available from Siemens. This ranges from the 8DN8 for a rated voltage of up to 145 kilovolts, through the 8DN9 for up to 245 kilovolts that you have just seen, and the 8DQ1 for up to 550 kilovolts, to the 8DR1 for 800 kilovolts. Siemens has installed more than 6,000 gas-insulated switchgear bays since 1968. At the same time, the technology and housing shapes have been constantly enhanced and perfected. The 8DN8 switchgear, for instance, is, with its bay width of 80 centimeters, the smallest system in the world for rated voltages up to 145 kilovolts. This compact design was achieved by triple pole encapsulation of all components within the system. The three-position switching device combines the functions of a busbar disconnector and a work-in-progress earthing switch. The circuit breaker is the key element in the system. Its interrupter units are installed in a hermetically sealed aluminum enclosure. SF6 gas serves as the insulating and quenching medium. The interrupter unit operates in accordance with the self-compression principle. When the circuit breaker is closed, the current flows through the main contact. During the brake operation, the arcing contact conducts the current. This prevents erosion on the main contact. An arc is produced on separation of the contacts. It reaches a temperature of up to 20,000 degrees Celsius. This thermal energy increases the pressure of the quenching gas. It flows through the contact cylinder into the breaker gap and quenches the arc in a few milliseconds. The arc's thermal energy reduces the necessary operating energy to the pure motion of the contacts. This makes it possible to use a stored energy spring mechanism. It is housed in a corrosion-free aluminum enclosure separate from the SF6 gas compartments. The operating mechanism motor charges the opening spring. After release of the cam, the circuit breaker is closed via the corner gears and the opening spring is charged at the same time. Directly after this, the motor charges the closing spring again, thus also preparing the circuit breaker for any necessary auto reclosure. Independent of the closing spring state or failure of the auxiliary energy, the braking force is always available. In this example, a current transformer is integrated in the circuit breaker enclosure. In turn, the feeder module contains a three-position device which combines the feeder disconnector and the work-in-progress earthing switch. If required, a voltage transformer and a make-proof earthing switch can be fitted. If required, surge arresters with metal oxide resistors will limit any overvoltages occurring. The 8DN9 GIS, for rated voltages up to 245 kilovolts, which we have already described, is, with its bay width of 1.5 meters, the smallest type in its performance class in the world. Its bus bars are also three-phase encapsulated. The bus bars linked to the circuit breaker can be interrupted via disconnectors. A pin contact serves as the work-in-progress earthing switch. In this type of GIS, the interrupter units are single-phase encapsulated. They also operate in accordance with the self-compression principle already mentioned. The stored energy spring mechanism supplies the making and breaking energy. At the same time, corner gears transmit the energy to the three interrupter units. A pin contact serves as the work-in-progress earthing switch. For measurement and protection tasks, an inductive current transformer is installed after the circuit breaker. Above it, we find the feeder disconnector, the make-proof earthing switch with its stored energy spring mechanism, and above the cable sealing end, the inductive voltage transformer in a gas-tight enclosure of its own. The proven switchgear for voltage levels above 245 kilovolts likewise benefits from progress in application and production technology. Here is an 8DQ1 for voltages up to 550 kilovolts, for instance. Its interrupter units operate in accordance with the well-proven puffer principle. Two quenching nozzles made of arc-resistant graphite are bridged by the moving contact tube with spring-mounted contact fingers. The puffer cylinder grips over it. The complete circuit breaker is filled with SF6 gas. On contact separation, the cylinder and the puffer piston condense the gas contents. The blast lattice releases the flow of gas. This cools the arc and blows it into the quenching jets. In only a few milliseconds, the arcing gap reaches its dielectric strength without restriking. This switching operation calls for considerable operating energy. This is provided efficiently and reliably by an electro-hydraulic mechanism. Siemens Berlin Schaltwerk Switchgear Factory. The state-of-the-art infrastructure and production process guarantee the high quality and long-term reliability of our high-voltage GIS. Computer-controlled machine tools, equipment that makes work easier, and qualified, highly motivated staff make sure that the high-quality demands are met. Every important production step is followed by tests and inspections. Precision measuring equipment confirms adherence to the narrowest of tolerances. Components are assembled to make modules, and modules are assembled to form complete shipping units under clean room conditions. Hermetic sealing of shipping units before they leave the assembly halls makes sure that all GIS interiors stay clean in the long run. These springs supply the operating energy for interrupter units up to 245 kilovolts. The Siemens test laboratories in Berlin belong to PELA, the Association for High Voltage Electrical Testing. The largest surge power generators in the world used here produce a test power of 90 billion volt-amperes for a fraction of a second. This represents the output of all the power stations in Germany put together. It goes without saying that all test stands are accredited in conformity with European Standard 45001. As a transmission network that spans the world also has to withstand natural disasters, Siemens switchgear is subjected to the tremors of a recorded genuine earthquake. In many countries, proof of seismic withstand capability is required before high-voltage switchgear can be used. All Siemens GIS types have one thing in common: compact design and low switching noise. This makes them particularly suitable for use in urban areas. Their hermetic encapsulation makes them safe to touch, prevents the ingress of dirt and dust, and also makes them resistant to aggressive atmospheres and extreme environmental conditions. A substation bay leaves the assembly hall after final item testing. Its compact dimensions facilitate factory assembly to form multiple bay systems. This simplifies transport and speeds up installation and commissioning. This saves the customer time and costs. In the new Berlin industrial complex near Leipzig, an 8DN8 substation with 7 bays attends to distribution of a reliable supply of power. Digital bay control technology takes the place of electromechanical monitoring and control elements. This includes DBC, standing for Digital Breaker Control, a module for safe and reliable control and at the same time for continuous monitoring of the circuit breaker's status of operation. Digital bay control offers more information about the status of the system thanks to constant diagnostics, early detection of faults, and optimum visualization of all operating data. Rent-A-GIS is the name we have given to our new service. We offer our customers in power supply corporations and industry the latest technology on a rental basis, for example, to bridge periods of repair or expansion projects. This idea was a reaction to practical requirements and experience, because nowadays mobile container stations are used by important power supply corporations to make sure that an uninterrupted supply of electricity is ensured in the long term during unavoidable expansion or conversion work. Siemens has gathered more than 30 years of experience with gas-insulated high-voltage switchgear all over the world. The world's largest 420 kV substation, for example, is in operation in Saudi Arabia. Siemens handed it over as a turnkey project with all control and protection facilities in 1990. In China, a substation comprising 5 8DQ1 type bays for 550 kV was constructed in close cooperation with the customer. It links the world's largest pumped storage power station with the power supply network in the south of the country. In Canada, a 500 kV substation with a breaking current of 100 kiloamperes was to be linked to the overhead line network. The SF6 insulated tubular conductors are welded on site. A total of 3,000 meters of tubular conductor link the indoor switchgear to the extended overhead line. Innovative assembly and laying techniques now enable efficient use of gas-insulated tubular conductors as an alternative means of transmission, even over long distances. Because even the most high-grade technology has to be operated and monitored by human beings, Siemens also trains customer personnel. Basic and special knowledge are imparted at the Berlin Schaltwerk switchgear factory, or on your own premises, entirely according to the wishes and needs of the respective customer.
We have a moving contact pin. You see, we can move it.
We also provide comprehensive service. Be it to support you in your maintenance work, for the swift delivery of spare parts, for monitoring your installation, or for quick help in an emergency. Specialized Siemens personnel are available around the clock. With proven technology and innovative ideas, we face the challenges of the new millennium. For optimum utilization of all energy sources, by linking the most distant regions of the Earth with a power transmission network that spans the world. This is why we are already working on solutions for tomorrow to make sure that the lights won't go out anywhere in the world.